So hello नमस्कार to the all chemistry lovers and doctors and engineers of the near future. मैं विजय कुमार सोनी आपका स्वागत करता हूं केमिस्ट्री वाला चैनल पे रिगार्डिंग टू एज यूजुअल केमिस्ट्री. Today we'll go with the just isomerism in haloalkane and haloarine. So this is the topic isomerism. Isomerism you are discussing the 11th standard. Two or more compounds having same molecular formula with a different, just you can say, physical and chemical properties, those are known as isomers, and this phenomenon is called as isomerism. If you will go with the haloalkane, then these exist position. First of all, it will be chain and further position. Chain, comma, position, and optical isomerism whenever that is asymmetrical carbon atom. Optical isomerism. I will tell you what is the meaning of just what will be the optical isomer. Now the time to discuss about the haloarine. Then haloarine only disubstituted haloarine exists only position isomerism. As you can say ortho, meta and para, there are three position isomers for the benzene. To explain these statements, we'll take just 3 to 4 most important examples. So we can take as a question, calculate total isomer for C4H9Cl. It is the best question of the NCERT also and board question also. Question number 2 is your calculate total isomer for C5H11Br. This is the second question. Third question, calculate total isomer for C3H6Cl2 as a dihalide because there are two halogen atoms. Question number 4, calculate total isomer for, you can say, this is the C6H4Cl2. Next we can take calculate total isomers for C7H8Cl. These are the important questions for the chapter 10. We will take one by one, which is very important. So we can take it over here, one by one question. If you will go with the first question, then this is the question number first, C4H9Cl. There is one halogen atom, so it will be mono haloalkane. And regarding to 4 कार्बन, आप कैसे लर्न करें तो मैं आपको बता चुका हूं सब्स्टिट्यूएंट्स के बारे में कि 4 कार्बन के लिए आपके पास में 4 सब्स्टिट्यूएंट होंगे. इट विल बी N iso secondary and just tertiary. So here will be 4 isomer. What are they? Listen me carefully. First is your CS3, CS2, CS2, CS2Cl as a N isomer. You can count 3 to 5 to 7 to 9 and 1 Cl. Another we can take iso. Remaining carbon will be here. On balancing CS3, H, CS2, and we can take Cl also. Another third is your This is the secondary. This is the Cl, CS2 and CS3. And if you will go with the fourth isomer, then it will be your 3 degree like this. CS3 and CS3 and Cl. So there are 4 isomer. We can write here. There are total 4 isomer, which are chain as well as position and optical. How? Chain, this is the normal chain, this is the iso chain, this is the secondary, and this is the tertiary. If you will go with the position, then this is the number 1 position, this is the number 2 position. So there are 2 position isomer and 4 chain isomer. If you will go with the word position and chain, another is your optical isomerism. For the optical isomerism, there should be following condition: C, A, B, C and D. And if A is not equals to B is not equals to C and D, then both 4 group are attached with the carbon are different, then that will be optical isomer. And if we'll go with the condition, then this condition is obeyed by the third example, that is called as 2-chlorobutane. So it will also as a optical isomer. Optical isomer. So anybody ask you how much carbon should be for the optical isomerism for the haloalkane, then you will say 4 carbon atom, and that will be as a 2-chlorobutane. If we'll go with the nomenclature, then it is 1-chlorobutane, it is 1-chloro-2-methyl propane. You will count the chain from this side. This is the 2-chlorobutane and this is the 2-chloro-2-methyl propane. So this was about the first question. See the matter properly. Now I would like to go with the second question, that is the C5H11Br. It's also a very important question because of it is from NCERT, and I will discuss with the syllabus to syllabus, not just less than, but will take more than also. So now the second is your C5, question number second, C5H11Br, and we have discussed about the C5H11. It will be 8 substituents. What are they? N, iso, neo. Further, secondary active, iso secondary active, secondary active, and 3 degree. What are they? First of all, this is the one, N as a normal, CS3, CS2, CS2, CS2 and CS2. Here will use of Br. So this is the first isomer. Further iso. For the iso, here should be 2 methyl group. Remaining carbon will be over here 1 and 2. This is your Br. Third is your, what is that? CS3 neo, CS3, CS3. This is the CS2 and Br. Further, we can take secondary active. This is the CH, Br, CS2, CS2 and CS3. Further, iso secondary active, CS3, CHBr. This is the CHCS3 and CS3, iso secondary active, fifth isomer. We can take further over here. This is the sixth isomer. This may be as a CS3, CS2, CHBr and CS2, CS3 as a secondary pentyl bromide. Seventh isomer we can take over here. This is the CS3 and it will be your active also. CS2, CHCS3. This is the CS2 and Br. And eighth isomer will be your over here as a, you can take 3 degree, CS3, CS2, CS3, and this is the Br. So the right answer for this is your, here will be 8 isomer. 8 isomer. There may one of the question also, कि how much 1 degree will be, 2 degree will be, and 3 degree will be. This is very important question. We have discussed regarding to 1 degree as a, it will be CS2x, for 2 degree CHX, and for 3 degree it will be CX. So this is your 1 degree CS2x, this is your CS2x 1 degree, this is your CS2x again 1 degree, this is your CXX, so 2 degree, this is your CHXX as a halogen atom, so again 2 degree, this is the again 2 degree CHX, this is the CS2Br, so it will be CS2X as a 1 degree, and this will be your 3 degree. So how much 1 degree? 1, 2, 3, and this is the 4. 4 isomer will be as a 1 degree. As a 2 degree, 1, 2 and 3. So 4 and 3, 7, and 1 will be as a 3 degree. So it will be 8 isomer. If anybody asks you how much molecule or compound for the C5H11Br will be optically active, then you can take as optically active, it will be fourth compound, secondary active pentyl bromide, it will be isosecondary active pentyl bromide, and it will be active pentyl bromide. So here we can say 3 will be as a optical isomer, 3 optical isomer. So this was about the second question as a C5H11Br. Read the method properly because these questions are too important. Now I would like to go with the third question, that is your C3H6Cl2. It is for dihalide, and we have discussed for the dihalide it will be 3 types as a xaminal, vicinal, and alpha omega. So this is the third question, C3H6Cl2. Question number third, C3H6Cl2. First of all, we'll take just xaminal. Regarding to this may be as follows: CS3, CS2, CH, Cl, and Cl. If we'll go with the next, then we can take another xaminal. This is the Cl and Cl. If we'll go with the further vicinal, then we can take CS3, CH, this is the Cl, CH2 and Cl. Neighboring 1, 2. These may be over here 1, 2. Both are same. And final is your alpha omega dihalide. Alpha omega dihalide as follows. So this is the 1, 1 dichloropropane, this is 2, 2 dichloropropane, this is 1, 2 dichloropropane, and this is the 1, 3 dichloropropane. So here will 3 isomers for this question. 3 isomers. So this was about the C3H6Cl2. 2 of gem, 1 of the vicinal and 1 of the alpha omega dihalide. Now the time to discuss about the fourth question. What is that? Listen me carefully because it's too important. You can see here is the 6 carbon. So we can guess it should be aromatic also. So what is that? This is the question. C6H4Cl2. This is the question for C6H4Cl2. For 6 carbon it will be benzene, and for benzene it will be 3 position isomer as a ortho, meta and para. This is the Cl and Cl. This is the Cl12 position is ortho, 1,3 position is meta and 1,4 position is your para. So here will only 3 isomers as a ortho, meta and para. Now the time to discuss about this is called as O dichlorobenzene, M dichlorobenzene, P dichlorobenzene. Now the time to discuss about the final question, that is your C7H8Cl. So this is the C7H8Cl. For this it will be 3 position isomer like this, ortho, meta and para. What are they? This is the CS3 and Cl. This is the CS3 and Cl. This is the CS3 and Cl. Ortho, meta, para, chlorotoluene. 3 position isomer. You can count the carbon 1, 2, 3, 4, 5, 6, 7. Hydrogen 3, 4, 5, 6, 7. And this is the 3, 4, 5, 6, 7. And C7H7, sorry, it should be C7H7. You can change here also. This is the C7H7. So again we can check. Here is the 1 carbon, 2, 3, 4, 5, 6 and 7 carbon. Hydrogen 3, 4, 5, 6, 7. Okay, and 1 of the Cl. So these are the 3 ortho, meta, para. Now we'll take just 2 isomer also. One of the as a benzyl chloride. You can count the carbon 1, 2, 3, 4, 5, 6, 7. Hydrogen 2, 3, 4, 5, 6, 7 and 1 of the Cl. So this was about the just regarding to the formula C7H7Cl. So here will 4 isomers. 4 isomers. So this was about the total isomer for the question, and these questions are too important. So we'll meet in the next video with the preparation methods of the just haloalkane and haloarine. Till then, धन्यवाद, शुक्रिया.